Alright, so welcome to part 2 of our exercises 2.3, part A. As you can see, we filled out our tables for volume and stuff, so if you're looking at that and that doesn't look familiar, just go back to our other one and it'll teach you how to get those values that you've got there. Now we're going to talk about these ones in between. So let's go to number 2. It is based off this table. It says if we have the unit for length is inches, and the unit for width is inches. So we have 5 inches by 7 inches. So we're doing a rectangle. It's 5 inches by 7 inches. Oops, sorry. Looks better if I have a rectangle. So let's say we have a rectangle.
Let's say he has 3 things for us.
This is going to be our 7-inch side. And this is going to be our 5-inch side. Alright, so when we're doing this, when we're doing perimeter, all we're looking for is the outside. So it's in one dimension, because we're not looking for the inside, and we're not looking for these squares on the inside. We're looking for just the outside, what the outside line equals. What's the distance to the outside line? And so with perimeter, our units is asking for perimeter area. Our units will always be just inches. Whatever our units are for our other thing, they're going to be that. Same thing with question 3. It says that what if our perimeter is centimeter, or if our units are centimeters? If our units are centimeters, our perimeter is just going to be in centimeters. And then question 3 is also asking, like, so it's asking, like, what are the areas for perimeter and area, and what if the length and the width of the thing is centimeter? But area is different. We're looking for all these little squares on the inside. If you notice, each square, it is a square. So we're counting how many squares are in there, but they're square inches. So we say it like this. We say inches. Area is inches to the squared. Or whatever we have, centimeters to the squared. This is true for everything. It's true for everything. This next one, and we'll show you how to do the formulas here in a second. This next one is going to ask us if it's in circumference and area. Circumference and area are the same thing. So circumference equals perimeter. So if that's true, then this one, it says it wants it in feet, so this would be feet. And our area would be feet squared. Right? And then this next one is asking for kilometers. So our C would be just in kilometers, because it's 1. And our area would be in kilometers squared. Alright, now this one is different because we've got a third dimension that we're dealing with. Sorry about that. So this third dimension we're going to have, it wants to know, because we're doing a cone, it wants to know lateral surface area and volume. So surface area, lateral surface area is equal to a perimeter. But they're all in multiplication. So it's always going to be in inches squared. It's not equal to our perimeter. It's equal to our area, because it says area. So the hint is that lateral surface area is going to equal, if it wants it in inches, then it's going to be inches squared. And our surface area is going to be in inches squared. And then if it's in volume, now volume is different because we're using 3 different variables. We're using 2 r's and an h, because we're using r squared, and we're using an h as well. So because we're doing it that way, we're multiplying it that way, and this one's addition, so we don't have to worry about that. This is addition. That's why we only get inches squared. But with volume, we get inches cubed, because we're dealing with a 3-dimensional shape, and that's how you know. Because we're dealing with inches on the height and 2 inches on the radius. We're squaring the radius. And so we get this right here. Technically, this formula should read like this: 5 inches squared, or 12 inches. Therefore, we get 3 inches throughout our multiplication. So that's going to be inches cubed. Show you real quick how to build a formula. Sorry about that. So to build a formula in Excel, if you refer back to our other ones, we need to know
That's a good answer. That's what I would think.
all right, sorry about that. So you're going to take this and you're going to build a formula. So we need to know our formula. So we're going to go back to page 66 of this book. So for this one, we're building a formula for our perimeter. So we're going to type it in like this. Whenever we're doing a formula in Excel, we always want an equals. Every time. We're going to say that we want 2 times little star is multiplication, this cell. So you click on the cell you want. Add it to 2 times this cell. So if you see, that's 2 length, 2L, times 2W. And that gives us 31. That gives us our perimeter. For area, we do a similar thing. We just, except instead of that, we just say this cell times this cell. Now if we fill that table in, we can drag this down like this where the little cross appears. If we've done it correctly, our formulas will appear correctly. And that looks right because that matches what we've got in our book as the answer. Now for circumference, our formula is 2 pi r. But we can't put pi in because it won't understand that. So we say equals 2 times 3.14596. We have to add that decimal. Then we say r. So we want to click our radius cell. Like that. When we click the radius cell, that references it, and we hit enter, and then it goes good. We drag it down like this, and it fills in the holes. Now we do our area, which is pi r squared. We say equals 3.14596 times r squared. So we need a parenthesis so we can tell it to square the r. This cell, little caret, to show that we're squaring it. Then that will finish off our formula for that. That will then help us to click that, and that is now our area. If you see, our formula is still up here. And if we drag this down, you know, this formula is D21 to the 2. This one is D22 to the 2 because it references a new cell now. And that's what happens when you use the cross. So always, when you see this cross, you can drag it down and reference new cells. Same thing goes if we're going to build our one for this one. We're going to say we're going to take 2. We're going to have our equals. We don't have our equals when we're 2 times pi 3.14596. Anything with circles has pi in it. It's the universal constant for circles.
So you write as you write if you need
R times L. Oops, no 2 pi. Sorry, I was looking at the wrong formula. It's just pi RL. So pi times R times L. That gives us our formula. Take this, drag it down. Alright, now, same thing here for surface area. We're going to take this one. This is going to be done a little differently. We're going to need parentheses to start it out. 3.14596 times R. We need another set of parentheses to tell it that we're going to square just the R. And you have to make sure to close both sets. So the reason we're doing this is because now we have to add this. I want this to multiply this out before it adds anything else. Alright, and then we're going to take this and we're going to multiply out for surface area. It's pi times R times L. See that? So that should produce this. So we take our D30, right? So we should check if we referenced all the cells correctly. D30 is radius, right? So we take our radius, reference that. We wanted to square that because in our original equation it's squared. Multiply by pi. So we did that correctly. Added this. We have our pi again times R times L. That is our total surface area of that one. We take this and we take our volume. Volume is going to be a little tricky. Oh, remember this, we can just take it once we get across, drag it down. Volume's going to be a little tricky because we have that pesky 1/3. You need a parenthesis to begin. And we'll also need 2 parentheses here in the beginning. I'll show you why. So we need a parenthesis to begin around that so it knows to divide that. We'll take this. So it puts that in the right place. Add our pi number. Sorry about that. Add our pi number, and then we take our r squared.
I actually got it prepared, put it down. Sorry about that, I appreciate it.
So if you see this, we're missing something here. Well, this is going to work out fine.
Sounds good.
We've got enough parentheses in here that this will work out fine, but we need to also multiply it by our h. And then do this. Close the parenthesis, because that closes the first parenthesis. So we've got these inner parentheses which help us describe what we want where. And that should give us the volume. Yep, it gives us a good volume answer. Drag it down. Now the book always has the answers in it, which is nice. So in this one we go down here and we can check our answers. They're a little off because our value for pi is not exact, but that's fine. Nothing else is wrong about it, it's just our value for pi is not exact. So these answers would be right. If you want, you can fill in the exact answers by using the exact pi, but it's hard to do in Excel. It doesn't like pi, and so it's hard to put it in there, so I just put it in with that many digits. You can keep adding. You can look up more digits for pi and keep adding those. But this will help you, hopefully help you understand what's going on with this exercise in 2.3. I'll make subsequent videos for 2.2 and send them off to you. But this one should help you understand for what 2.3 is asking. If you have any questions, just email me. Anything I want me to clarify, I'll either make a video or email you back. However I see fit best to do it. Alright, and that should do it.